Here's Ishnur Kaur from Amrit Indo-Canadian Academy studying in +1 Medical. This is my video assignment for subject Chemistry, Chapter 1, Basic Concepts in Chemistry. Today we will learn about mole concept. Mole is defined as the amount of a substance that contains as many elementary particles as the number of atoms in 12 grams of carbon. Mole is simply a unit to count very large number of particles like atoms, ions, molecules, electrons, etc. and is equals to 6.022 into 10 raised to power 23 particles. These much particles are called 1 mole. This number is also called Avogadro's number or Avogadro's constant. The symbol of mole is MOL. The mass of 1 mole particle is called molar mass. The unit of the molar mass is gram per mole. Mole concept in ionic compounds. 1 mole of an ionic compound represents 1 mole formula unit of the compound. Mass of 1 mole of ionic compound is equal to its gram formula mass. Standard molar volume. Mole is also related to the volume of gases. At 273 Kelvin and 1 atmosphere pressure (SGP), 1 mole of any gas occupies 22.4 liters of volume. This volume is called standard molar volume. Mole of atoms. 1 mole of atoms of an element has a mass equal to gram atomic mass of the element. 1 mole atoms of an element is equals to gram atomic mass of the element. For example, the atomic mass of oxygen is 16 and therefore the gram atomic mass of oxygen will be 16 grams. The symbol of an element represents 1 mole of atoms that element. Symbol O represents 1 mole oxygen atom and 2O represent 2 moles of oxygen atom. Mole of molecules. The mole of molecules of a substance has a mass equal to gram molecular mass of the substance. For example, the molecular mass of oxygen is 32, so the gram molecular mass of the oxygen will be 32 grams. The molecular formula of a substance represents 1 mole of molecules of that substance. Formula for number of moles, number of particles and mass of a substance. Number of moles N is equals to M upon capital M, where small m is the mass of the sample and capital M is the molecular mass of the substance. Number of particles capital N is equals to small m upon capital M multiplied by NO, where NO is Avogadro's number. Mass of the substance M is equals to N multiplied by M, where small m is the mass of sample and capital M is the molecular mass. Now, we will learn how to use these formulas. So, let's do some numericals. So, our first question is to calculate number of moles in 392 gram of H2SO4. In this question, we are dealing with molecular substance. So, we will use the formula N is equals to M upon GMM. We know that given mass is 392 gram and we have to find the molecular mass of H2SO4. So, it will be 98 gram. So, we will put these both things in this formula and we can find the. Our second question is to calculate the number of moles in 44.8 liters of CO2 at STP. We are given with the volume at STP, that is 44.8 liters. So we will put this in this formula and we can find the answer. Our third question is to calculate the number of atoms of the constituent element in 53 gram of Na2CO3. So in this question there are three steps. First is to find the number of moles, second is to find the number of molecules, and third is to find the number of atoms. So we are given with m is equals to 53 gram and we can find the GMM-SO4. So it will be 106 gram. We will put in this formula and we will get the number of moles is equals to 0.5 mole. In 1 mole there are this much of molecules, so in 0.5 mole it will be multiplied by Avogadro's number. So in 1 molecule of Na2CO3 there are 2 Na, 1 C and 3 O. We will multiply 3.011 into 10 raised to power 23 molecules with the number of, so we will get the number of atoms in each molecule. Thank you.